Hello and welcome to this video, which is a demonstration video of the Navacal Scantling Calculator. So when you first open Navacal, this is the main screen you come to. It'll ask you to create a new project. So I'm currently in a project named Test. But if we go to File, New Project, and just click New Project, this is the screen you'll see when you first open it. If you have projects created, then you'll see this screen when you first log in. You choose a project. So if we choose the test project for now, just go through all the inputs quickly, and then I'll go into one of my existing projects and show you the calculations working. So as you can see up at the top, we've got several drop down menus. We've got the file menu where we just went into new project. You can save and save as the file you're currently working on. So if we go into load, you'll see that we've got one file saved in this test project, one Scantling file. It's only the files created in the Scantling Calculator you can see here. And then you can save multiple Scantling files as part of one project, so you can iterate through and change the design and save several examples of it. In the editors menu, we have edit materials. So all of these are the default materials that Navacal has built in. So these are the main materials, which is commonly used aluminium, steel, polyethylene and wood. We've got fiberglass resins, fiberglass reinforcements, which is, as this calculator uses the ply-by-ply method with laminate theory, this is the elastic modulus of the base material, so not with any resin added, not like the simplified method in ISO 12215. So just for info, if you go to add any additional custom reinforcement materials, make sure it's the bare fibre details you're inputting into here. Core materials, so these are all the core materials defined for when you're doing a sandwich construction in fiberglass. And again, any one of these, whether it be main materials, resins, reinforcements or cores, you can add new custom core materials and transfer them between projects. Settings, it's just a switch from light to dark. In the calculators menu, we've got all the additional calculators, which I'll make separate videos about. And this is the drop down where you select which standard or set of rules you're using for the Scantling calculation. So currently within Navacal we have ISO 12215, BV NR 600 or Lloyds Special Service Craft. And the about section is just a list of all the calculators and everything built into the program. So if we quickly run through the rest of the editors, so we've got edit adhesives as well, which is when you're using adhesives to bond stiffeners to panels. So these are the list of defaults that are built in, and again you can add new ones. We've got the shared resources, where you can download a zip archive of the project you're currently in, and then the upload project resources, you can either upload that that zip file I should say, or if you wanted to just use the materials or the stiffeners from that project, you can extract the zip file on your PC and just upload the individual materials, adhesives or project JSON file from that file you downloaded. And then in the file browser, these are a list of files saved within the project that you can delete out of the project from here. One other quick thing to note, so if we go back into the project list, you can see here you can delete projects from your account and you can copy projects. So when you copy a project, you can see it appears here, and it'll have all the materials, all the stiffeners that you've created in the original project in that new one. So we'll delete that for now and go back into the test one. So this is the main general input page. So up here you select from the main material type, as you can see. If you choose fiberglass composite, it then opens up a different menu underneath asking for the layer input method, which we'll go through as we go through the panels. So you can either use fiber masses in grams per square meter, which is what the program defaults to, or you can enter it in finished layer thickness. Just to note, if you are in BV or Lloyds, it's only fiberglass, steel and aluminium that are available for use in those two calculators. HDPE and wood are only for ISO. So if you have a quick look down through the general parameters, the design ID and hull identification number, they export as part of the PDF and Word exports in the results section, results tab. You've then got hull type, which is monohull or multi-hull. If you select multi-hull, the wet deck structure appears with all the inputs. So these inputs change. Some are shared between the calculators and others get added and removed depending what standard you've chosen. So we've got the wet deck height. If you look here, we'll just go through the wet deck tab while we're in it. Each input box has got a tooltip that appears if you hover over the box, that shows you what to enter in that box. And then something else to note here, so for all material types, for all calculators, the wet deck panel configuration, so we've got single panel with external stiffeners, we've got a dual panel box structure, so when you have that selected you've got two separate decks, but the distance between the panels or between the decks is the height of the stiffeners in between, and it acts like a box structure, so the same stiffeners support both panels. And then finally dual panel independent decks, which then opens up another input box with deck spacing. And as we're in fiberglass on the general page just now, we'll have a quick look at how the layer stacks work. So when you're in fiberglass, for all of these different panels, you'll get the fiberglass options appearing. So you either got single skin or sandwich. So if you're in single skin, it's got resin type, which you select, and then the layer stacks on top of that. So as you saw in the general tab, I had fiber mass selected as the input. So if I go back to that again and change that to finished layer thickness, and then go back to the wet deck structure, it asks for thickness in millimeters instead of fiber mass. And then you choose the reinforcement from the list of reinforcements in the materials JSON. If you add any new custom materials, they will appear here. I'll just choose one. The number of layers, fiber mass, and then the fibre volume fraction. So you start from layer 1, and this goes from for single skin or sandwich. So layer 1 is the base layer, and if you want to keep adding layers, they go on top of the base layer, and then the ply-by-ply analysis in the back end calculation happens, and on the results page, as you'll see in a bit, we will see the finished layer thickness of all the combined layers, whether it be single skin or sandwich, and that goes for stiffeners or for panels themselves. And then if you were to change it to sandwich, the only thing that changes is you get an extra layer stack, so you get outer stack and inner stack, and then you also get the core material, which is a list of the cores again in materials JSON, and then the core thickness. But you add the layers for the outer and inner layers in exactly the same way. So if we go down through the general tab now, we'll put this back to mono hull. All of these inputs, like the length overall, fully loaded waterline, beam of the hull. Again, there's tool tips for each one. The beam at the fully loaded waterline and the chine beam, I've added an extra little thing here, which is a drawing showing where to measure the chine on a round bilged hull, and also what the measurements are that the calculation is looking for. So the beam of the hull input, as you can see here, is the A1 measurement, and then the beam at the fully loaded waterline, and then the chine beam, as you can see below that, is B1 plus B2, so the two hulls together. It says this in the tooltip here that pops up, but it was just to make it a bit clearer what exactly the calculator was asking for. The moulded depth of the hull, as you can see there, it's written in the tooltip, so it's the height of the hull from the keel to the gunwale or deck edge. The draft at full load, loaded displacement mass and maximum design speed, and then you've got design category, as this is the ISO calculator, operating mode, which is planing, displacement or sailing, and because we're in fibreglass, it's fixed to the enhanced method 2 in ISO, which is the ply-by-ply analysis of the fibreglass structure. And the next two boxes, hull girder inertia and deck height above neutral axis. So if you know them, you can add them, or you can leave them both as 0 or blank for an auto estimate, which is auto estimated from the full hull structure once everything's filled out. And then the last one at the bottom is the dead rise. So you can add a bottom or side panel, which will just create a new panel called bottom panel 2 or 3, whichever the next number is you're using, as you can see down here. If we remove that panel, as you can see here, I've created stiffener groups already, but I'll show you that shortly. And then we've got the duplicate panel, which if you click that, it duplicates the panel, all the inputs and all the stiffener groups down below. So we'll remove that as well. Again, the inputs change depending what calculator you're using, whether it's ISO, BV or Lloyds. We've got the same fiberglass input options with the layer stacks depending on single skin or sandwich, and you can either have it in single panel mode, which as you can see here just has all of these inputs that it asks for, or you can have it in multiple panels, which splits it into 3 sections, aft, midship and forward, so it's just 3 equal sections that the boat is split into. You put the panel length, the distance of the mid panel from the aft end of the LWL, and then all the other inputs as they were before. What that does is splits the panel and pressure calculation up into 3 separate sections, and on the results page it shows you the 3 separate sections with the same stiffener groups for each. Side panel, very much the same, just a button to add or duplicate. Some different inputs: deck height above chine, waterline height above chine, height from chine to gunwale, and again the stiffener groups down the bottom. Transom, again same layer stack information if you're in fiberglass. In the panel data section it asks for number of engines, so you can either have 1, 2, 3 or 4 outboards or outdrives, or 0 for sailing or inboard, which then removes the engine inputs. For deck, bulkheads and superstructure, they are all blank to begin with, but if you want to add a deck, bulkhead or superstructure, you just click add panel, and again as we're in fiberglass, the fiberglass options are shown: panel length and width, height above waterline, the distance of the panel from the aft end of the LWL, and then stiffener groups that you can add down the bottom. Bulkheads, very much the same, just the panel details, and then you can add the stiffener groups, and the same with superstructure. So what we'll do now is I'll show you how to add stiffeners. So we've looked at materials and adhesives and shared resources already. If we go into the edit stiffeners, so I'll give an overview of how the whole stiffeners editor works. So if you have these stiffeners already in stiffener groups as you saw throughout the project, and you want to change the size of it, say it's failing or it's oversized for its use. So say you wanted to change the frames and girders for argument's sake, and if the calculator was telling you with the spacing and unsupported length that it was passing by a few 100%, you could reduce the size of it. So you go to like one length and reduce it from 300 to 200, and then that will update through the program. So anywhere that stiffener's used in the bottom or side or transom or whichever panel, if you go and push calculate again at the end, the stiffener calculation will update for all of those. So if we go to add stiffener, we'll just call it test, and then if we look here in type, so we've got lots of different section types, and depending on which one you choose, it comes up with an image next to it showing what the dimensions are and what needs to be entered. Just go through each of them quickly. one thing to mention about plate, so where that's used is in the transom calculations. So if you have an extended pod transom, so you have the outer transom and then an inner transom and then a deck plate on top. The deck plate on top of the transom contributes to the section modulus of the calculation for the engine loads. So if you're calculating a transom like that, use the plate type stiffener for the deck plate on top of the transom stiffeners, and that will contribute to the total section modulus for the engine loads calculation, which I'll show you as we get to that. So for any of these stiffener types, you can either have any of these materials, which is the metal materials, and then HDPE or wood for the ISO calculator. And then right down the bottom we've got composite cord stiffener, which is a stiffener with a core from the core materials list with fibreglass layers wrapped around all sides of it. And then we've got composite single skin stiffener, which is any of these shapes just made out of solid fibreglass layers. So if we quickly look at the composite cord stiffener, you've then got the layer input method again, which is fibre mass or finished layer thickness, same as the main calculator. And the dimensions of the stiffener when creating it for a composite cord stiffener are the dimensions of the core itself. Then the calculator applies the layers on top of the core. So it's the layer, the core plus the layers. And if we were to change that to composite single skin stiffener, the inputs then change to height and flange width, and then the thickness comes from adding the layers. So as you add layers in the results page, you'll see the calculated thickness from the fibre mass calculation. And then for all stiffener types, if it's metal, you get the option of welding. If it's wood, you get adhesive bonding, which then opens up the adhesives list below that to choose which adhesive you're going to use. And for fiberglass, you get all of these options, and there's a tooltip here that you can look at which shows exactly what each one means. And then if we go to a metal stiffener, you can see that the fiberglass inputs all change, or disappear I should say. In metal or fiberglass stiffeners you can also add lightning holes. So the way to look at this is if it's a stiffener, say a girder running the length of the boat supported every 600 mil by transverse frames, you would look at it, so the whole width would be the width of the hole looking at the side of the stiffener over its unsupported length. So if it was 600 mil and you were leaving 100 mil at each end, it would be 400. And if the stiffener was say 300 mil high and you were leaving 100 mil all around, the whole height would be 100. And then that's carried through into the results, and the section modulus reduction within the stiffener is applied by the calculator. And as you can see here, welding, it's fixed to that for metal materials. We'll just click a wooden one. You've got adhesive bonding or mechanical fastenings, and then the adhesive drop down pops up. Okay, so what we'll do now is we'll open up one of my existing projects where all the details are filled out in all the panels, and we'll have a look at the stiffener groups, how they're created, how you can edit them, and run a couple of calculations. So we go to new project. This is a existing test project I have, and then we'll click File, Load, which will then give me a list of all the files saved within this project. So click this one, and as you can see here, so I've got Lloyds Special Service Craft regulations selected here, and all the details filled out. And then as you can see here, the Lloyds specific parameters appear when Lloyds is selected. And some of them are optional, so you don't have to fill them out. Right, if we go down, so this is the bottom panel, so we've got frames and girders. As you can see here, the same stiffener is used for both the frames and girders in this boat design. Must have duplicated them. So as you can see here, we've got the stiffener groups already created down at the bottom. So for each panel, I'll just go through creating a stiffener group. So if we click Add Stiffener Group, it adds it to the bottom. You give the group a name, just call it 1, 2, 3, so it's test. For each panel, the orientation changes. So for bottom, you've got longitudinal and transverse. Structural roll, we've got primary, secondary, or natural. Stiffener type, so this is a list of all the stiffeners I've created for this project, and any stiffeners you create in Stiffeners Editor will appear here. We'll choose frames and girders. For the bottom panel and the side panel, it's one side of the bottom and one side panel you're running the calculations on. So if we look here at the number, so if the panel was say 1200mm wide and you had say 3 girders running and their spacing was 0.4 meters, or say 0.4 meters with a 400mm spacing from the keel out the way, and unsupported length is the length the stiffener is basically unsupported. So for a longitudinal girder or stringer, it would be the distance between the transverse frames, and for a transverse frame it would be the distance, either the width of the bottom panel if there's no longitudinal stiffeners, or the distance between the longitudinal stiffeners, whichever. As you can see, depending what standard you have selected, we've got Lloyds optional settings where you can set the stiffener structural roll. If you don't fill this out, it uses primary, secondary, or natural from the structural roll up here, and then the position of the stiffener, which is, it auto sets it to the mid span, between the mid distance between of the unsupported length of the stiffener. And then if I go out of this and change to BV and then look in the stiffener groups again, you'll see that there's an option that appears to add end brackets or gussets to the stiffeners with all the inputs for that. So rather than creating gussets in one of the editors, you just create them per stiffener group by filling out these details. And there's a bit at the bottom, so you can either use the same material that the stiffener is made from, or if the bracket material is a different material, you can then use the drop down which takes you to the materials editor. And as you can see, these were just test materials I made as custom materials. We'll go back to Lloyds again, and if we look through the rest of the panels, you can see all the details are filled out. There's a few extra inputs within that Lloyds calculations need as compared to ISO. Breadth at section and distance of the panel at the aft end of the LWL. I'll just have a quick look through all of these. And then look in the superstructure here. It's an additional Lloyds input here, so we've got the superstructure category from Lloyds. And so basically, if you go through each tab, fill out all the details, the tooltips are there to help out, and then once everything has been filled out, what you can do is you can switch between Lloyds, BV and ISO and fill out all the different inputs that each one asks for, and then click save here, and that saves all the inputs for all the calculators. So then you push calculate. As you can see here, it says Lloyds Register Special Service Craft and gives all the details of the calculation with the Lloyds calculations in the background. You see the breakdown of each panel. You can see side panel 1 and side panel 2 where it's been split up into two panels like we looked at before. And then if you want to, like I was saying, you can switch between, because I have all the inputs filled out for this particular file that we're in, you can change the standard up at the top and just click calculate again, and it calculates it to Bureau Veritas. It still passes, but all the section modulus is required, and web area share and various other calculations, as you can see here, change to the BV calculations instead of the Lloyds ones. And the pressures and everything else. And then finally switch up to the switch to the ISO calculator and just click calculate again, and again the calculations passing, as you can see up here. But the calculations are the ISO ones in the background. just to show you the stiffener quickly, so if you look here, say these stringers for argument's sake, so we go into that in the stiffeners editor, that's the stringers here, and if we change that to 50 by 6 and then push calculate again, you can see that anywhere that stiffener is used, it then changes the calculations in the background, so you can quite quickly optimize a design to the standard that you're working to. And finally, before finishing, I'll open up a fiberglass design. Make it a multi-hull so we can see that. So again, same with this one. It's Lloyds Special Service Craft, but you can fill out all the inputs and switch between the different standards and compare them if you want to. So as you can see here, we've got the layer stacks defined for all the different panels, and the stiffeners, which are composite stiffeners. Same with the side, we've got the layer stacks, core thickness, core material, sandwich panels. All of these are sandwich panels. And as you can see here, we've got the different inputs that appear for Lloyds. The superstructure, we've got that as a single skin panel in this design. And then if we go and click results and calculate, you'll see a lot of the outputs similar. So we've got the stiffener spacing showing the unsupported span of the panel, but then we've also got the detail of the sandwich panel as well. And all the, in this case, Lloyds sandwich checks, deflection checks, panel buckling checks. Stiffeners, as you can see, have all the layers and resin and everything else shown here, and all the standard references for the calculations. And then if we switch it to BV, for instance, click calculate again, a lot of similar details, but got the BV specific calculations. Yeah, it's quite a detailed report that the calculator puts out, and then you can apply the Lloyds deflection limit and ISO wrinkling checks if you want, and it adds them in for each sandwich panel. And then go into the ISO calculator, click calculate again, it shows the ISO output. So we've got each panel showing in the same order that it shows up here, and then right down at the bottom for all the different calculators, we've got the global loads, whether it's multi-hull or mono-hull. Global loads show for BV and Lloyds for mono-hulls as well, and then the longitudinal strength calculation. And then just to show you, if we, so this is the ISO calculation, export to PDF, as you can see here, it shows you the calculation results with the layups of the fiberglass thicknesses, etc. It's basically all the detail off of the results page, which is laid out by panel in sections. The Word file is exactly the same. If we change this to Lloyds, push calculate again, and then export PDF, you'll see that it has the Lloyds output, and then all the standard references next to each calculation as well, and the same structure. And the Excel export just exports it. Each panel has its own tab, and then there's a summary tab, the same as what we have here. And then we've got a snapshot of all the inputs down at the bottom of the Word and PDF exports as well. Okay, I think that's about it. If any questions, please leave them below or get in touch on the info@navacal.com email address. And thanks for watching.